Okay, Bo and I are back on our MX500 project, and we left off with wanting to kind of rig it up and take some runs, and I'm not sure where we'll have those runs put in here. I think we'll do some after ones for sure, but maybe I'll throw in the midway point runs where we're using these old batteries. These batteries are about a year old, and I decided to replace all four because it wasn't lasting all that long. So where we left off was with our wiring, and what we found is the wiring for the new controller is different than the old controller. The old controller had male terminals that you would take from the factory harness of your brake switches and throttle switch, and they would plug into them. The new controller has females, and so the problem is we can't plug any of these in. And what I didn't realize is in the kit with the motor, or in the kit with this, I'll show you. When you buy the controller, or you can look this up online, and this was my fault that I didn't see it. This came actually with the controller, and notice it's the wiring harness. I think I may have shown that a few times, but check it out. They give you the connectors, the mating connectors, and a part number, and I totally didn't even see it when I was ordering parts. And anyway, I ordered the connectors so we can do this properly. And it's been actually a few weeks. There's other ways we could have done it. We could have cut all these connectors off and wired it and soldered it, and that would have been fine too. But my issue was, if this controller ever goes bad, I want to be able to unplug it and just plug a new one in. So I wanted the connectors. Now, what I did to get it running without the proper connectors, I found a lot of these were optional, but there was a few that I needed. I used this connection off of, I believe it was the battery of the battery connection of the old setup. I cut this connector off, and I'm using that for my main power and ground. Sorry, this is my motor control wire. The yellow and blue are the motor control, and then what I used for the main battery, which is this one, was the old motor. I took a connector off of that, and I just needed that for a mating connection. So really, this is not the motor anymore. I'll take that sticker off. That's not motor. That's my old motor connector that plugs into my controller, main, battery, power, and ground. Okay? So I needed those two connected, the motor power, and this is the controller power. Let me restate that. Main power to the controller, and this is the output from the controller to the electric motor. Those two, and then one other connection you needed, and that was the one that says lock. There is a 2-pin, it's blue wire, says lock. This thing wouldn't do anything unless we jumpered the lock. And really what this is a switch. When we connect this up and when we wire this, I have a switch for it. That's basically the on-off switch of this controller, and with that alone we can run this system. Now, of course, we had our new throttle sensor plugged in, and they did give us the mating connector for that. You guys remember Bo and I wired that, so we did have our throttle plugged in. What we didn't have plugged in when we test drove it was our brake switches, which I really want to get these on there for safety reasons. And so I needed to do that. And but anyway, that was our setup to get this thing running. I wired in the 4th battery, and I'm not going to go through that part because we're going to do a complete wiring of the batteries. But we have our connectors, we're ready to go, and Bo has to say something. He has a little bit of a cold, so he sounds a little sniffly.
Can I go get something real quick?
Yeah.
Okay.
Go ahead. Just real quick, the additional parts that we ordered cost me $13 with shipping for the rest of this, and I actually ordered 5 of the CNX51 connectors because I plan on potentially putting a headlight and brake lights on this. I wanted to have some extra connectors for that. And then this one I won't need probably. I got 2 of those, and that was the motor and battery connectors because I used old parts for that, but I ordered those too. So 13 bucks isn't bad. I just wish I would have known that when I bought everything else. I would have got them with it and we wouldn't have had to wait. One other thing I forgot to mention when we were finished, our motor, when we ran it, it actually ran backwards. So when I wired this plug, I just kind of matched up the red and black on my old connector here, and what happened was it was backwards, and so it was actually an easy fix. I just popped the pins out and switched them, and so if you ever do this conversion and your wheel is spinning backwards, no big deal. Just pull the pin, switch them over, reverse polarity on the DC electric motor. I didn't hurt it at all. I just made it run backwards. So that was my fault for not really paying attention to what I was doing. I kind of based it off of the old connector, and I couldn't do that because all of the connectors are wrong. So here's my bag of connectors. This is the way it comes. We got a little bit of work to do to get these right. So we have our soldering gun warming up. Bo is going to do the first one for me, and it looks like they give me the CNX51 is this connector, and they give me both sides. I won't be needing both sides because this already has half of it on there. What we want is our male side because we have female terminals. So Bo, we need 2 male pins here. I need you to hold this for me. Let me back the camera up a little bit. Bo's got a little bit of a cold. Say hi to everyone, Bo.
Hi.
He sounds horrible, but he's okay. Alright, so here, hold these. These are called male terminals. The ones, hold your hand up so we can see it. Those are male terminals. Those are, and then these are called female terminals. Okay?
Are they gonna mate?
I was wondering if you were going to ask me that, but we're not going to talk about that right now. Bo knows all about that already, but we're not going to have that conversation right now, Bo. Okay, so what we need to do is we need to, I want to get our brake switches connected, Bo. Okay, and our brake switches are these guys. And really a brake switch, polarity is not really important. What these brake switches do is they just close. And so the polarity of the brake switch, I'm not even going to look it up. I mean, I'll match red to red and black to black, but when you're dealing with a switch, it is not critical. And so what we need to do is we need to cut these off. These are our female, okay? The terminals are female. Bo's still smiling. You see the difference in the males and females. The male terminal,
Fixin'.
for obvious reasons, okay? Okay. That's kind of funny.
I didn't mean to.
No,
put
that's
it like
fine.
that.
No, it's fine. It just is what it is. So we're going to cut this off, and then we're going to put these on, and then we're going to clip them into here, okay? And that way we'll be able to plug them in. See, when we're going to use this connector, and that's our charge rate battery capacity. That's a gauge. We have to make sure we pay attention to these. That's my stoplight switch. It actually says it on here. This one's my charger. Something else I forgot to tell you guys. This would not charge without the switch, which is called the lock switch. So your lock switch needs to be on for this thing to charge the batteries.
Yep.
And we had to leave the jumper in for the batteries to charge up. So another tip there for you guys. So we'll take that out. We don't need that anymore. Brake switches, Bobby. We need those that tool over there that strips the wires. That cool tool right there. Yep, you got it. And I got these goofy cutters right now, but this will work. All right, these are our brake switches. We're gonna cut these off. I'm gonna leave some wire just in case we ever need these terminals again. Okay, those are coming off. Do you remember how to use that tool?
It's like you clamp it down.
Yeah.
Like
You want to see if you can do the black one?
Let's try. I'm gonna try.
And what we want, wait, before you clamp that down, watch your shoulder so we can see what you're doing. We want to take off just the end of that wire. Hold on, not yet. That should work right there. Squeeze and pull. Do it. Open it up. Let's try it again. I'll put pressure on the top. Push down. Wait. A little bit more. Let go.
What?
Let up. Yeah, there you go. Okay, wait. All right, now do it. Okay, good job.
I fell on my foot.
A little
Are we
bit
gonna do
frayed
it
on the
with the
end.
red
Yep, we
one?
need the red one too. Hang on. Hopefully we're seeing that. Go ahead. Go ahead. Pull. Good job. That one was nice. Alright, so here's how this will work. Let's get a zoomed in shot of what I'm doing. This is going to go, you know, you don't need to solder these maybe, but we're going to solder them. This bottom part, the bigger part of this, is going to hold the insulation, and then the other part is going to hold the copper part of the wire.
Are we gonna smash it though?
We are. So it's going to go like this.
How are we gonna solder it without destroying it?
You'll see what I'm going to do. I cut a little bit of this wire off. We had too much. Don't play with those right now.
Okay.
They'll just make noise on the camera. It'll be annoying. Okay, watch real close what I'm doing here, Bo. I want you to see this. Okay, so the wire is in there. And what I'm going to do is I'm going to fold over the copper and pinch the wire. Are we catching that? I'm going to, I don't think we're going to show all of this on film. We're going to show some of it. So that's holding that part, and then we bend. Shoot. Ah, darn it.
Do we need another?
Nope. We'll be okay. It's getting dark on us too, bud. I'm gonna have you do one bow, and then you can go. Okay.
Are you gonna do this by yourself?
We'll see. Okay, can you see real close how I did that?
It's like one folded and then the other.
Yeah.
Kind of like a tortilla.
Yeah. And then what we do is we fold this part. I'm going to zoom out a little bit because I think I'm missing some of this. I'm going to fold this part over the insulation, and this is going to hold it nice and tight. Okay?
Okay.
This is very, very tedious. I think you could do it though. You're pretty handy.
Looks hard.
Yeah, it kind of is, just from getting these terminals right, because it's so small. That's ugly. So that's one. Okay, but we're not happy with that. What we're going to do is solder that.
So it doesn't fall off.
Yeah, is my solder up there, Bo? You see it?
Yep.
Up on the tailgate?
See it.
Okay, bring it here. Okay, what we want to do when we solder this is when we're going to hold the gun below, we're going to put the solder right in here, okay, Bobby?
Okay.
I'm going to hold the gun there, and hold on, let me just clean this off a little bit. Because these guys will get on me about a dirty gun. This is a butane gun, it's not electric, and it is clean, even though it doesn't look like it. And then just a little bit, don't get it up in here. We don't want any solder up here.
Okay.
Just on this part right here, okay? Touch just a little bit on the gun first, just below it. Wait. That's it. Just like that. With a little point. See that little point on the end? We don't want that guy there. Let's get him off there. Cool?
Yeah.
Alright, then what we're going to do is that terminal is going to get put in here, but we want to make sure that when we do it, that we're connecting it up the right way. So let's zoom out. This is the charger. I want a brake switch. Where is a brake switch? Stoplight. Battery capacity. It's cool, this has a lot of stuff to it. There is a brake switch right there. Is there only one brake switch on this? I really wanted two. Stoplight. Charger. Battery. Oh, see, this has two brake switches, Bo. 1 second, then you can go. What we'll do, Bo, are you watching?
Yeah.
What we'll do with this for our brake switch is this one. It's green and black. And again, I don't really care which one's which for a switch. If any of you are worried about that, there is brake switch lever, green and black. Yeah, even on the wiring diagram, it's not real clear. I mean, it gives us the color, green and black, but again, it's a switch. I'm not worried about it. You can put this pin wherever you want. And Bo, I want you to fish this pin into this connector for me, okay?
Yeah.
Here.
Go from your angle.
You can do it from your angle.
Solder still kind of hot. So we'll go like this.
See this fat part right here? See the little finger? That goes
Yeah, it goes.
on the
I got it.
okay.
Right.
And when you push it in there, it'll click.
I think the solder's blocking it, maybe.
Might be my connector.
I think I got it.
Let's see. Is it in all the way? Yeah, I think you did.
Just
Nope, needed to go in just a little bit more. That solder was interfering a little bit, wasn't it?
Yeah, so let's solder this one.
No, actually what it was my crimp connector. Good, that's one. Cool, man. Thanks. I'm going to pause it there. We're going to wire some more of this. Maybe I'll talk about some variables along the way. We're not going to film every step of this.
Bye.
Okay, guys. My partner left me, but that's okay. He's not feeling too well, and hey, he's 9. So I have a concern with this. As I'm looking at all my connectors, I thought I had more than one brake switch, and I do not. There's only one input for the brakes on this, and I have 2 brake switches. So just for safety reasons for me, because this bike is a lot faster, and if something would happen and the controller would stick and keep the motor on all the time, I want to have both of my brakes, my inputs. And so what I'm going to do is I'm going to tie these together. I'm going to resolder this one that I did. I'm going to put both brake switches together. So temporarily, what I'll do is show you guys, well, let me do them individually first. This is how we would check your brake switches. Is just using an ohm meter, going 1 lead to each. And what we should have is an open circuit. I'm just on a 1K ohm scale right now. See if we can see that. And that says OL, and that's on a 1000 ohm. Really, the true open would be on the 10 mega ohm scale. And we actually have some readings here. Okay, there's 1 million ohms. It's open. I'm going to go back down to my 1K scale. Okay, and then what you would do is you squeeze the brake switch. I'm just up top. I'm reaching up and grabbing it. So that's my right handle. That's not the right one. This is my left brake, and it should go to 0 ohms. Let it go, and it goes back to open. Do it a couple times. Okay, So that is a working functional brake switch. And then what we would do is you go back to, or go to the other side. Polarity is not important. 1 ohm meter lead to each of the wires. And we want to do the same thing. We should be open in one mode. Try to hold this still here. And then we reach up and grab the brake. 0 when I pull the brake. So as you can see, it is just an open closed switch. Alright, so now what I want to do to show you that this will work is we're going to tie these together. I'm going to put my 2 grounds together. And then my 2 2 blacks. I don't want to call them grounds. They're not grounds, it's a switch contact. And then my 2 reds, for now I'll just use my multimeter lead, my ohmmeter alligator clip, and hold these together. Okay, so there's both of the reds together on the 1 ohmmeter lead, both of the blacks together on the other. So basically I have a parallel circuit here. It's not a series circuit, it's parallel. You see I have the same thing. I am open. Okay, and I'll reach up, grab the right side brake, and you see it drop to 0. So it's switch closed, complete circuit, open circuit, closed. And then I'll do the same thing, reaching over for the left brake, closed, open. This one's sticking a little bit. This brake is sticking. That's going to be an issue for sure with this left. I'm going to have to adjust that cable. Okay, but basically what I'm showing you guys is that is how we can use both switches with one input. And the way that the controller would read that would be if it sees a closed circuit on either one of these, it's going to shut power off to that motor. Okay, so I'm going to wire this up in parallel like this for this new controller. It's getting dark on me, guys. Here's my black connection. I did the red one, and see, I'm going 2 into 1. I folded that over. You know, some of you guys don't need this part, but some of you probably will. And then the insulation part. This part isn't all that critical. We could have put all copper in there and not squeezed the insulation at all. It really doesn't matter. Just when you see factory connections, they will do them this way frequently, where we'll pinch the wire and the insulation on the one part and then just go bare on the other part. Okay, that's not good enough for me. Definitely want to solder this. Just don't think that that's making good enough of a connection. Again, I'm using a butane soldering gun, and as you can see, nice and hot. Flick some of that solder off. This will flow real fast. My trick for me is put a little bit of solder between the piece you're soldering and the gun. Makes a little puddle, transfers heat real well after that. And that's it right there. Any extra solder that would be on there as it's hot like that, just give it a little flick, and little field way to get rid of the extra solder. It's a little bit blurry in that shot. And then let that cool off for a second. And we'll put this pin in here. Be a little bit tight because we have the extra wire in there, and I'm actually using my pliers to kind of push this in there. Push that pin. Be nice if I had my pocket screwdriver on me. I need to go grab it. Actually able to grab it from the front side. You got your two male terminals in there. And so what we do now with that, find the one that says brake, stop light. The stoplight's going to be an output, battery charger, stoplight. This is my brake switch. And mate the two halves together. Okay. And I have black. My blacks are going to black. And the green is going to red. Again, it does not matter for the brake switch. Polarity is not important here. Either way for the brake switch. So now both brake switches are wired. And will be a nice input to this controller. Alright, important piece I think I'm about to do, and that is to get rid of this crap. I don't like it. So what it boils down to is any connection that you make is a potential voltage drop, and so we don't want that at all. I don't want any kind of a drop, so I'm going to make this a much better connection than what I had. Although, you know, what I had was pretty decent. I guess what I'm saying is just a more reliable one, and more weatherproof too. And these are a little bit big. I don't know if that's gonna work. I just bought these little barrel pieces. Let's see how these crimp. They don't crimp very easily at all. I don't know if I can even use that. Yeah, I bought these at a flea market. Yep. That's pretty tough. I mean, I'm gonna solder anyway, but yeah, I'm not a huge fan of this at all. I mean, it should work. I was hoping for something a little bit better than that. But this will be sufficient, I think. So I crimped them with my cutters, and then I'm gonna flow some solder in there. And I'm not gonna waste my time here with that. We're gonna go right with the torch of this tool. It is windy. That's always great for camera work. Next to this tire. Yeah, I don't like that barrel connector at all. Should have left the one that I had on there. That looks like crap. A piece of heat shrink. It's supposed to be the good stuff. We'll see. Again, I bought this at the flea market too, so. Hate shopping. Love a good flea market though. But we want to see if this is the good stuff like they told me it was. I want to see some sealer coming out of this, and I do. Good. Well, don't like the barrel. It's giant and ugly. But that worked for that one. So for this one, I'm leaving this connection alone. And what I'm going to do is okay, I'm going to use that. Let's put this one back in first. Bend this tab back out. Losing light. I have to stop filming. Bend that tab back out. You see that? Okay. And then we put the terminal back in, it'll hold. I gotta pull this one out, squeeze that terminal in. Pull it out. I'll show you this last one. And then we're gonna stop filming for the night. It's getting too dark. I realize this flame is next to this tire. Not the safest place to have an open flame. Does that cool off? It's way hot still. At least the heat shrink's good. Here are the robins in the background. That is Pennsylvania's state bird. Not sure why. At least I think so. And they make all kinds of different chirps, different noises. They're super annoying in the morning when you're camping out in the woods. They start yapping about 5 o'clock in the morning before the sun comes up. 4:30 maybe. All right, that's enough for now. Well, I lied. I'm still here, and it's dark now, but I think I have enough light to show you this part. I am wiring in my on-off switch for this whole thing. It basically shuts the controller off, and it's totally different than the original design. It's considered a lock. It's really the only thing that makes this thing you know, shut down. So what I'm going to use is the original. I'm going to use the original switch, the original on-off switch, and just basically on the inside I got rid of the plug. Right, just pulled that off of there. This is the setup for it. And what the original design would do is it would interrupt power to one leg of the circuit to the original controller, and it would basically disconnect it from the battery, I'm pretty sure. Forget the setup. And then there was actual on-off power feed to the other controller, where this controller has power all the time, and really can't change that. That's the design with this. I can't use this setup anyway. So I don't know if I'm going to have an issue with that. I'll have to do a little bit of playing around if this will actually charge when you disconnect battery power to the controller, and I don't think that it will. No, it definitely won't, because I need it to go, the charger goes into the controller, and then, yeah, no. Anyway, so I'm going to leave the wires a little bit long for this. I'll have this part already pinned, okay, and then these two. With this particular switch, it was a multi-function. It interrupted two circuits, but they're both on the same switch, so I can use either side. It doesn't matter. And for this switch, guys, this switch is non-current carrying. It's not carrying any kind of loads, so I'm not worried about soldering this and making sure that I have absolutely sound, I don't want to say sound, this is a sound connection, this butt connector, or this crimp connector I'm using. But I'm fine with that for this, because all it is a switch input to this controller to say, okay, go ahead and turn on. So again, it doesn't carry any current, and I'm just plugging in to each side of the switch, and it doesn't matter. I could have used the top part or the bottom part of the switch, and that'll give me my input that I need for this. If I had charged batteries in here, I could show you right now that this functions. This piece here is my charger, and that fortunately has already the right connector on it. So battery, it says battery capacity, that's not it. Charger is the one where that goes. Obviously you'd want your red to red, black to black. And really, that's kind of ready to go. There's my on-off switch and my charger plug. And I really just got to wire in the battery. The rest of this is, see, this is battery capacity, so I could put a gauge on this one. The remaining connector, just one, is a stoplight. So I could put a stoplight in here, and that'd be an output. When I hit the brakes, this would send voltage out, give it a power and a ground, light a light. So that's it. That's my only other connection on this. The next step is the batteries, get those wired up, and then I'll show you maybe some voltage readings so everybody's comfortable with what I'm doing and what I'm showing here. But I need to wait probably till it gets light out.